comets are big balls of ice that are in orbit around the sun. And there are winds that blow off the sun's surface. They're winds of ions, particles, like little bullets shooting out of the sun in all directions. And so as this big ball of ice, a comet comes around the sun, the solar winds blow material off of the comet out into space, and the tail always faces away from the sun. That's what a comet might look like. If you saw one at night, there's the ball of ice, and this is the debris that's being blown off of the comet from the solar winds. Comet, solar winds. Where is the sun? It's below the horizon, right? So as the solar winds are coming off in all directions, if there's a ball of ice there, that debris is being blown off directly away from the sun. There's another comet. And another. This is interesting because you see how the comet is moved. It's moving in this direction, but the debris is blowing off directly away from the sun. See it? Space is empty, right? So if there's nothing out in space and there's a big chunk of rock moving through space, it's not going to be blowing material behind it, right? Because that would imply some kind of friction. The friction would cause the material to blow behind it. But is there any friction? You can't have friction because there's nothing out in space. So if there's something coming off a comet, it's not due to friction. It's due to something hitting it like little bullets from the sun. So the solar winds are hitting the comet and blowing the material off. So the direction of the tail has nothing to do with the direction of the comet's moving, right? The direction of the tail has to do with the position of the comet relative to the sun. So that means when a comet is coming into the solar system, its tail is behind it because it's coming toward the sun, which is what you would expect if you're thinking about friction, which doesn't exist. What happens when the comet's leaving the solar system? Its tail is in front of it because the sun is behind it and is blowing the material out in front of it, which is counterintuitive, but that's what's happening. It's actually chasing its tail when a comet's moving away. That's a test question. The tail of a comet is always facing directly away from the sun. Has nothing to do with being behind the comet. It may be behind the comet in terms of the way it's moving when it's coming into the solar system, but that's just because the sun is in front of it. Where is the sun? It's below the horizon, but you see where the tail is? Always pointing directly away from the sun. So, got lots of pictures of comets. We had the Hale-Bopp comet that came through, about 20 years ago? Went out and saw it with my son. And that was by far the best comet I've ever seen. Halley's comet comes through, but it was very faint last time it came through. Japanese sent up a probe. They got good photographs of it. I think I've got some pictures of it. Yeah, here's some of the photographs taken of comets from out in space. You can see the debris is trailing. Anyway, there's a comet in front of the Helix Nebula, the planetary nebula we looked at. This is just showing the orbits of some of the comets. So you can see there are certain comets that have very straight orbits. They just come in, go around the sun, and go back out. Others are more typical of a comet, even though they're shifted to one side or the other. You see the light blue comet? What is it doing? This light blue? Can you tell what it's doing? It's progressing around the sun. It's like what do they call a spirograph? In other words, if my pointer is the comet, it's doing this kind of thing. Through time. It's progressing around it. Most of them are in a nice stable orbit like this or like that. Photographs of some comets have been taken by probes. You can see the icy crust on it. Oh, they are moving extremely fast, but since the space is so vast, it takes a long time for them to transverse that part. And there are probably a lot more comets out there. We just haven't seen them because we haven't been looking long enough with our telescopes. Those are just the ones that we've seen because they happen to be coming around the sun in this particular century when we have telescopes. Anyway, this is just showing the debris that's being blown off the comet around it. There was a large comet that hit Jupiter, and they believe there was a comet that hit the Earth back in the 1800s. I'll show you evidence of that. But this comet was in the way. Jupiter was in the way, and they got photographs of what it did to the upper atmosphere when it punctured it. So that comet's no more. Don't worry about that one. It's now part of the mass of Jupiter. Anyway, this just shows the debris from the comet that hit the surface.